Hello everyone, welcome to another webinar in this series of webinars that we have been conducting in the last 1 month or so. This is Mohit Jotwani. I am part of the product management team at DataTorrent, and I have with me my colleague Mr. Hitesh Kapoor, who is a software engineer at DataTorrent and a committer at Apache Apex. So today we'll be looking at a streaming ETL application which has been customized from an app template, which basically reads from a JDBC input store and writes to a JDBC output. I would request people from the audience to just raise their hands if they are able to hear us clearly. So there is a question panel available at your end. If you have any questions, we would be more than happy to answer your questions as much as possible during the session. If not, then we will take most of the questions at the end of this session. So at the end of this session, the YouTube video as well as the deck would be available on SlideShare. This would be available shortly. So you could actually look at them after the session is over. So the agenda of this session is to look at the vision with which DataTorrent was formed. We look at the key points of DataTorrent's vision. We'll briefly touch upon Apache Apex, which is basically an overview of the architecture. In the past, we have conducted quite a few webinars. There is quite a few YouTube videos available which talks about Apex in detail. Then mostly we'll be looking at app templates, the concept of app templates that has been introduced in the last month or so. We would look at a particular app template from database to database, and my colleague Hitesh would basically give a live demo where he would take this app template and try and create another ETL kind of pipeline application to see how an app template can be easily customized to an end application. We'll then look at the roadmap for this particular app templates, what exactly we'll be offering in the coming few months. So DataTorrent, the people at DataTorrent basically came out of Yahoo with a vision that they wanted to productize big data. So when we look at the ecosystem around Hadoop specifically, and if you look at the ecosystem around big data, there are quite a few offerings within the ecosystem from different players as such. But when we talk about whether they are clearly productized, whether they are in a shape that can be easily operationalized, then there are quite a few challenges that every player faces. And this, I'm sure the audience would also agree based on their experiences in the big data space. The other part that the team was really focusing on was the total cost of ownership. Now, the total cost of ownership does not nearly implies to the cost of an ongoing operations or basically building an application, but also the time to develop an application and the time that it requires to launch a big data application. So the operational expenditures, the maintenance expenditures, the cost of overall development of the application, the time to develop an application, and ultimately the time to launch and maintain an application. These are quite a few big features that should be considered when one talks about total cost of ownership. So how drastically this total cost of ownership can be reduced. The third part and another key part was to provide a product which allows developers to build their applications very easily and rapidly, so that they don't have to worry about the operational challenges as to how an application would run, how it would scale, how it would recover when there is a crash or something goes wrong with the cluster, any node in the cluster, or any process that way in the application as such. So they would mostly focus on the business logic that they have to code and deploy in the cluster. So for that, what kind of simple interfaces or pre-built apps or reusable code and very clear way of debugging your application that has to be provided. From a development support perspective, what all tools are available, what can be provided for a particular team that they can test their application. They can take it from, let's say, a proof of concept stage to ultimately into a production and launch it very easily and quickly. And ultimately, once it is launched, once it actually goes into a production environment, how do they visualize how the application is behaving, how it is being managed? And from an operability perspective, these are some of the key challenges and the requirements from these big data applications. So this has been the vision. This is what we have always considered. And based on this vision, you will see the roadmap changes in Apex. You will see quite a few features that we provide in our enterprise offering. So they are all focused on ensuring that developers are able to create their applications easily. The total cost of ownership in terms of the actual cost, because it's native to Hadoop, the time to develop an application, the time to launch an application is considerably lower. And ultimately, to provide you a product which allows you to build your big data applications in as simple and elegant way and allow you to maintain it in as simple and elegant way that is possible. So when we talk about next generation big data applications, so what exactly has been happening around in the ecosystem? We've seen a variety of sources that have popped up in the last 5-10 years. When we talk about data coming from social media, so unstructured data available from the likes of Twitter API, from bots that actually scrape this data, from further applications that have generated a fair bit of this data, from the Internet of Things where a lot of sensor data that is available, from newer types of sources or things as you would like to call them. So a message queue like Kafka, from your traditional file systems like NFS or new file systems like HDFS, newer stores, some of the new NoSQL stores, graph databases, and so forth. So the variety is huge and the data is growing exponentially. So what people are looking at, what product could actually support these sources, provide the data in as low latency as possible and as high throughput, and ultimately that they could actually visualize this after providing the business rules, the business processing logic on this data in a real-time scenario. The other change that has happened from traditional applications to these new big data applications is the way we look at data. So we've been used to data at rest. We've been used to bounded data where we would stage data and then actually start processing that particular data and then apply some logic to that data. So that has changed and we moved from bounded to unbounded continuous data streams. So the likes of social media, IoT, message queues are continuously pumping in large volumes of data for a batch scenario and even for a real-time processing scenario. Then we are moving from processing data by persisting it, mostly accessing disk most of the time, moving from that particular scenario to actually in-memory processing with temporal window boundaries as such. So there's a windowing concept that is being introduced. And then obviously having stateful operations where one would like to aggregate the data, one would like to apply complex event processing on this particular data, one would like to apply different business rules, different analytical patterns to this particular data. So if you look at this particular slide at the end, this is the picture how it looks like. So this is what we also refer to as a directed acyclic graph or a pipeline in the terminology of Apex. So imagine a client, which is basically a browser, is generating a lot of logs. So from your web server, you're actually consuming these logs via, let's say, a Kafka cluster. And ultimately, you're decompressing these logs, you're parsing, you're filtering these particular logs, and applying some kind of stateful operation like an aggregation or deduplication or some business rules. And ultimately, you're writing this data to some persistent store, which could be a message queue like Kafka or some JDBC-based store or a NoSQL store. So this has been kind of a nature of the next generation big data applications, and people are generally looking for such kind of solution which can quickly consume this data, process this data, apply certain complex algorithms on this data in motion while the data is being processed mostly in memory, and ultimately get insights from this data. So where does DataTorrent fit into this particular big data ecosystem? So if you look at this particular picture, I'll just focus on Apache Apex and the layer above Apache Apex, which is basically joining three particular operators. So Apache Apex is a big data, distributed big data processing engine, which is native to Hadoop. So Apex effectively is a Yarn client where Apex utilizes Hadoop's uh, resourcing capabilities. So it basically relies on Yarn to provide the resources, basically the memory and the processing power for what we call an application which is built from these operators. So when someone builds an application over Apex, it's basically these operators. There's a library called Malhar, where we have some 300, 400 dot operators, which includes connectors where you could read data from different sources, sensor data, social media data coming via, let's say, an Amazon S3 or a RabbitMQ or a Kafka message queue, or through Flume pipeline or through Solace systems or the JDBC input store, so forth. What we basically require as our prerequisite is for a Hadoop 2.2 plus cluster to be deployed either on on-premise or on a cloud basis or in a virtual environment. So it could be any environment, it could be any distro, it could be a MapR or Hortonworks or a Cloudera distro, or even vanilla Hadoop is fine. You could be on cloud on Azure or on Amazon EMR, so forth. So basically, Apex relies on Yarn's resourcing capabilities. Apex does not come with an inbuilt scheduler. As part of the roadmap, we are also considering Mesos. So going in the future, down the year, we would possibly be utilizing Mesos as well. So an application is built out of these operators. So basically, we build a directed acyclic graph, which is based on true streaming engine Apex, which has built-in fault tolerance, scalability, and it takes care of all the operational challenges that one faces. So an application developer would not have to focus on these particular challenges. So this is what we meant by the total cost of ownership, that one does not have to worry about these challenges. So you can think of a really large cluster, like a 100 node cluster, where you would like to deploy your application, which, let's say, reads from a particular store, does a fair bit of complex processing. There are integrations that you might want to do with existing applications. You want to read data or write data to them, or reference data from that, and ultimately perform some analytics and get some business value out of your data. So basically, an application developer would just have to focus on that business logic. And the deployment, the launch of the application, that entire part, the tools are provided in Apex and around Apex as such, where an application developer can easily launch the application in no time. And as part of the enterprise offering, we provide real-time analytics and visualizations, which you could actually see on the enterprise offering by DataTorrent, which is called RTS. So if you look at an overview of the DataTorrent's architecture, so these are the layers. So at the bottom layer, as I just mentioned, we basically need a Hadoop 2.2 plus cluster. Basically, Apex utilizes Yarn's resourcing capabilities. So it could be an on-premise cluster, it could be in the cloud, it could be a virtual environment. As part of the DataTorrent downloads, we also provide a sandbox which you can easily deploy on your local machine and try it out. On top of that is the core, which is the key part of this entire architecture. So the Apex core engine, which has got built-in fault tolerance, which takes care of the entire scalability, which ensures very low latency and high throughput as desired by your application developer as such. So this is what the engine takes care of. On top of this, there's a development framework, what we basically look at as a development framework, of which the Malhar operator library is a key part, is a key element, which has quite a few operators, some 300, 400 odd operators. So these are available on GitHub. You can download them from the Apex website at Apache. So some of the connectors that you would see in the coming app template are basically connectors to different data sources. There are quite a few processing operators which transform the data, allow you to transform it, allow you to enrich the data. You could integrate it with a machine learning library like NH2O or a Dato or R, and where you could do the modeling and do the scoring part within the Apex pipeline. could actually write an SQL query, put that as an operator within the pipeline, as we have integration with the likes of Calcite. You could actually write your own OLAP store, for example, and introduce it into the pipeline and actually do a slicing and dicing of the data as the data is being processed in memory. And there is a high-level API which developers can use. So this is currently in Java. So developers can use this high-level API and bring their own pipeline on top of Apex. We have a full batch support where you could actually take this unbounded data and define some boundaries over it and ultimately run the application as a batch. It could be scheduled. It would start and end as per the schedule. There are integrations with the likes of Apache Samoa and Apache Calcite. So in Calcite, basically it allows you to write a plain SQL query which actually gets executed as a DAG over Apex. The above layer is what we'll be looking at are the application templates. So when we looked at the particular ecosystem and after talking to most of our customers and our prospects, we realized that there is a common pattern where we see quite a few of these templates being talked about. So we decided to come out with some of these templates as part of our enterprise offering. So you'll see quite a few of these. These are basically Java app packages which are kind of pre-bundled as part of the enterprise offering. So you would see things like Kafka to HDFS. So basically you'll have to configure a Kafka operator and the HDFS operator, and you could just deploy it on a production environment and so forth. As part of the enterprise offering, we provide a management and monitoring console where you can actually see what's happening with your application in the cluster, how things are behaving within the containers of the particular operators. You could actually see a real-time data visualization, basically the metrics that are coming out of these operators. So you could actually see how the data is moving across in the application. And this entire processing is happening in memory. So we only persist the state of the operators. We have a concept of checkpointing the state of each of the operators so that if it crashes, we bring it back from the last committed checkpoint. Again, some of these concepts are vastly covered in our previous webinars if you look at Apache Apex. And then there are some solutions that we provide in terms of for ingestion, for data preparation, and certain ETL pipelines. So this is the entire DataTorrent offering. If you look at the architecture, if there are any questions at this stage, we can take certain questions regarding Apex or DataTorrent RTS. So coming to this layer of app templates, so basically when we look at some of the engagements that we've had with our customers and our prospects, and in general what we got from as a feedback from most of the people in the ecosystem. So these are some of the recurring patterns that we would see. So if I look at a machine scoring, for example, they would read data from Kafka, they would do the modeling in an H2O or in R kind of environment. So ultimately, we would actually get the score from these libraries and pass on the score within the application and ultimately persist it in a sink like HDFS. Similarly, for data synchronization or for enrichment of data or merging data from multiple sources and then ultimately transforming the data, filtering the data, enriching this particular data, and writing it, persisting it to some store like HDFS. So in a way, HDFS is turning out to be a major replacement for traditional warehousing stores. So looking at some of these common patterns, it made sense for us to actually bring out these patterns as app templates so that it allows you to take these templates, customize these templates and create your own application and quickly launch those applications and try out Apex. So these app templates are available as part of what we call AppHub. AppHub is available as part of the DataTorrent's enterprise offering, RTS, and quite a few of these app templates are also downloadable from our website, datatorrent.com. So these have been tested by our QA team thoroughly and published on the website and also available as part of the RTS offering. As part of the future, we are looking at version upgrades for these particular app templates, which you can visualize through our RTS DT managed console. So this is basically a central repository of all these big data application templates. When we say big data, it has been tested with a certain scale. So you can look at testing out these applications with a very large volume in terabytes of data on like a daily basis, and customize it and try out your own application based on these app templates. So what are the advantages of having these app templates? So as I mentioned earlier, so some of the things that a developer would want is some kind of a toolkit which allows a quick and easy launch of their own application. So if certain aspects of their applications are already taken care of, so like let's say reading data from a particular source, parsing the data, transforming the data, and ultimately writing data to a certain source, that basically gives an added advantage where they can just put their custom logic within this pipeline and quickly try out the application and launch it in a production environment. So it easily allows them to quickly develop this particular application. And then the time to the market and the total cost of ownership for this particular application. So let's say you have to get this application going in, let's say, a week's time. So these templates will help you in quickly building this application and taking it to production, whereby drastically reducing your operational cost. The additional part is you could really see some real-time visualizations of these operational metrics as to what is the latency, what is the throughput, and so forth. And you can also see how your application data is behaving. So what kind of files are being processed, for example, what's happening with a particular tuple, what we call as the data record that is getting processed within this particular application while it is being processed in memory. So if people are interested in an app template, you can look at it on our website, www.datatorrent.com/apphub. These are ready-to-use customizable applications. The source is available on GitHub. So this is the link, github.com/datatorrent/app-templates. So I will now hand it over to my colleague Hitesh, who will take you through this particular app template, database to database, and it will show you the code and how to create a custom application from this particular template. And later at the end, we'll talk about the roadmap and certain resources that will help you in playing with Apex and DataTorrent RTs.
And thank you, Mohit, for that good introduction to Apex. Hi guys, I'm Hitesh, and as you can see on our screens that the application which we are going to see from app template today consists of one input operator and one output operator. So operator is nothing but a centralized a point where it's a functional unit of your business logic, where you can write your code for a particular logic or any evaluations and stuff. So we'll just go to the live demo. So this is how your app template actually, this is how your DataTorrent console actually looks like when you actually download it and install it. To start using app templates, we will have to go to the App Hub. You'll have to click on the App Hub over there where I have clicked. When you click on the App Hub, you can see all the packages currently present in the App Hub. It has many already existing apps like HDFS to HDFS, Kafka to HDFS, S3 to HDFS, database to database, database to HDFS, so on and so forth. So today we are going to see an application for database to database. You can even search for a particular application. So we'll just go. And then the next thing is you have to import that particular application. So just click on the import. While it is getting imported, let me just tell you that app templates are a way to just ease the life of an end user. And without even using app templates, also you can do a lot more things than Apex using Malhar operators, or you can even write your own operators. If time permits, we will go and look at the code of how to actually modify an app, or how to modify and use our own custom operators and logic. So I guess it was the template has been imported. So we'll just go to the develop. And yes, so if you can see over here on your screen, we can see a database to database app sync app. We will just go ahead and launch it. So for launching or for doing any operations on any app, you will have to configure it. For in database today, we have an input table. So definitely we will have to give it, we will be using JDBC connection for that input table. So definitely we'll have to give the driver name, the table name and stuff. So this is the place where you do this. So you from this configuration file is nothing but the configuration of your clusters, or if you're using a inbuilt DataTorrent sandbox, you can specify that over here. So I am using a cluster memory configuration. I will show you this configuration files later. Then over here is the place where we can give the properties like the database driver, database URL and stuff. So there are some default values already present in it. So for my scenario, I need to change this database URL. So we have the username, the passwords, the table name. Please feel free to ask if you have any questions or queries. Okay, so I guess, yeah. So once we have configured our app, we will just go ahead and launch it. Oh, actually, yeah. So till it gets launched, I will just show you the current scenario of our input table and output table. So currently in our output table, we have 0 rows, and in our input table, we have 1,000,000 rows. So let's go ahead and look at the app. So as we can see, the app has started, it has started running. And over here you can see the DAG. DAG, as I explained earlier, DAG is nothing but a directed acyclic graph of operator. The nodes are the operators and the edges is the stream of data from one operator to the another. So you can see how the input operator is just processing records and giving to the output operator. Over here you can have some statistics of those. We have the number of processed records, total processed records. So now you can see that the input record has emitted, input operator, sorry, has emitted 1,000,000 rows, and the output has processed those 1,000,000 rows. Even in our operators, you can specify, there are concepts like partitions and stuff which will enhance you to speed up the operations of it. So we had provided some number of partitions, so that in the physical diagram you can see that there are 5 partitions over here. 4 are for the static partitioning cases and 1 is for the polar partition. We will not be going in the depth of that, but just keep in view that you can actually partition your operators depending upon the number of inputs, the amount of data you have, just to ease and just to decrease latency and stuff. So we'll just go and check the number of rows in the output table. Yes, now you can see that 1,000,000 rows have been added to the output table. As I told that we have a partition for a polar, which acts as the polar operator. So if we add new records to the input table, it will poll the input table and those records should get added to the output table. So we'll just add some records to the input table. Yeah. So I'm adding around 50,000 records to the input table. So let's see. So on our app, if you will go to the logical view, again, now if you can see that the total number of emitted records have increased and the total number of processed records have also increased. Similarly, you can see on the on our DAG as well. Now it has gone down to 0 because in that particular time frame, no records are being emitted. Also, you can see you can customize what you want to see in that DAG. You can see the total last heartbeat time, and on the top, like it will show you when the last heartbeat of that operator was received, like how healthy is that operator, or even you can say total number of records emitted, total number of records processed. So all these things are customizable, and you can see that not total, yeah. So total processes over here. Sorry. So you can see that thing as well over here. So on the input side, none of the records have been processed; they have only been emitted, and the output operator is not emitting anything; it is just processing the records. Okay, we'll go and just have a look at the output number of records in the output table. And as you can see, voila, we have added 50,000 records to the output table. So this is the power of app templates. This is the ease with which we can do the things. Okay, as I promised, I will show you a code base where we are adding one additional operator. And this operator is on our screens, as you can see, is doing nothing but just transforming the name to an uppercase and just emitting it. The code to do that is nothing but we have to add this code which is highlighted on your screens, and then to the DAG, as I said, physical, to our directed acyclic graph, we just need to add a stream from the JDBC input to the transformer. Before that, just let me say that the central part of an Apex application is this populate DAG method. Okay, so if we want to see a demo of this, we can just go to our, so before that, we will just kill this app, shut down this app, and by the time it is shutting down, we will go and truncate our output table so that when we run this app, even before truncating it, let us look at the current records, like how do they appear. Select name from output table, test underscore event underscore underscore table. So if you see, currently the names of the in the output are in lowercase, and our transform operator will now change this to uppercase and then emit the rows. So we'll just first truncate this table, this output table. Great. So now we will go to our AppHub. We will go to development, and I had already uploaded this package over here, database to database with transform, and I will go ahead and similarly I will just launch this. I will go and give my configurations. I'll specify the custom properties. Over here I need to change my database URL. Just go ahead and change it to my path. Also, one more thing, the transform operator which we used is already existing in our MapR library. And as Mohit had mentioned, it is a very rich library of 300 to 400 operators, and we are actually making it more rich day by day. We are adding more operators, and we welcome all of you to contribute in that, in our MapR library and also in our Apex code. So we have clicked on the launch, it will get launched, and as we can see, the application has been successfully launched. It has been accepted. We will just check over here. Okay, just so the application has started running. The operators have started. Over here, you can see that the DAG, now we have a transform operator in our DAG. It will take an input from JDBC, transform it, and give it to the output operator. Also, as I was telling you, the number of partitions. Now, we don't have a one-to-one partition with from JDBC input to output. Now we will have a concept of unifiers. I know these are slightly advanced topics, but just to give a gist of the power of Apex, we will look at this. So now, as we have a transform, as we have no one-to-one mapping with from JDBC input to output, the output will now have a single stream of data. So that is where this particular operation is taking slightly more time than the previous one. We could have very well have a parallel partitioning over here also, but just to give you a gist of how things are without parallel partitioning.
So there are a few questions from the audience. If you could just take some of those questions.
Yeah, sure.
So based on a couple of questions that are coming from the audience, so we just like to clarify a few things. So the app template that we are looking at is basically reading data from a JDBC based store. So any database store that has a JDBC connector that way, or basically a library that is provided via JDBC can be connected through this particular input connector and written via that output JDBC output connector. So there are inquiries about HBase, Phoenix, and Hive. So we have different connectors for these stores, which do not comply to the JDBC standard as such. But if you have the likes of Oracle, MySQL, or Postgres, and so forth, which have JDBC library as such, you could actually use that and with this particular connector to be actually utilized in this particular app template. In terms of Yarn, so Apex, as we mentioned, Apex is basically a Yarn client. It's basically an application which requests for resources from Yarn, similar to let's say a Spark application which might utilize Yarn for resourcing. So in short, we don't need a Hive or an HBase to actually run this particular application. We actually need a JDBC based store, like an Oracle or MySQL or a Postgres.
Okay. So we will just look at the effect of the transform operator, and as now you can see, the output is showing the name in uppercase letters. So this is how we build applications in Apex, and this is how you can tailor your applications as per your need. Okay. So yeah, so we have a question like how the load is running, so whether it takes blocks of records. So actually it doesn't take blocks of records. We are processing one record at a time. You can have in a vanilla JDBC application, you can set those settings like the batch size, fetch size, and so on and so forth. So it will take a batch and it will give that batch to the next operator. So it will not wait for any other records to come. If in a particular time slot, if there's a concept of windowing which could help you, and it will not wait for any record to come. It will just wait for an end window call, and it will just emit the tuples in that window. Is there any other question regarding app or app templates or? And as I said, this is just wasn't one of the examples of how you ingest from a GD table or anything. If you have Hive at your end, we have an Hive operator to do that in our MapR library. Also, you can plug and play on any input store. You can even take data from Kafka. You can take data from HDFS. Any further questions? So the output on the output side as well, when we output it to in a table, we output it in our JDBC output operator. It doesn't inserts it in a way like, okay, now one row has come, we will insert it. As I said, it's a vanilla JDBC code. You can have your own load size to it, batch size to it to achieve the same. You can have a look at the code of the operator itself in our MapR library. It is freely available, and you will get a gist of how the load is being done. There is in backend actually uses a transactional operator behind it to guarantee semantics like exactly once. Again, I don't want to go in the technical details of that part, but as there is a question of how the output is getting loaded, so the answer to that, it is done in batches and at some particular trigger. And the trigger is in Apex technical terms is an end window call. Any other question?
Yes, we can take this. So how can I install Apex?
How can I do it?
So the question is that how can I install the Apex project on my customers to do that things?
So I guess the question is how to get Apex or DataTorrent RTS on your production environment. So Apex is downloadable from the Apache site, apex.apache.org. The GitHub library, the link to that library is present over there. It could be downloaded from the Apache GitHub resource. DataTorrent RTS is downloadable from our website, www.datatorrent.com/downloads. We have a few versions of RTS. So there is a community version which basically does not have this visualization and the security aspect of the offer. There is the complete enterprise version, which is available for 90 days for people to try it out. We also have a program where you could try it out on a cloud basis, and there is a sandbox that you could download if you don't have a Hadoop cluster. You could basically create your VM on that and try it out in the sandbox as such. So these are the options that are available.
Okay, so I'll hand over to Mohit to take you towards the roadmap and stuff. Thank you. Thank you for the questions. You have been a lovely audience.
Thank you, Hitesh, for that fantastic session. So coming back to the roadmap for these app templates. So in the coming months, what we'll be seeing is default visualization widgets being added to these app templates. Users can actually use these widgets to view their metrics or even custom define their metrics. So these are auto-generated metrics coming from these operators, which are there as part of this particular app template. We will have app templates which are schema enabled. So basically, we'll be able to attach data schema. It is currently also available. You can easily define a schema for the data tuples that flow in an application. So most of these app templates would get schema enablement in the future. There are cloud integrations. We already have integration with likes of EMR and Azure. So you will see quite a few of these app templates being tested on these cloud integrations. You could actually try them out on EMR and Azure. All the current app templates that are there on AppHub can easily be deployed on any of these cloud environments. Some of the upcoming app templates are, you would see from FTP to HDFS, Kinesis to S3, and then ETL pipelines such as Kafka via certain parsers like JSON, CSV, with filtering and with transformation, and ultimately being written to HDFS. So as you can see, some of these ETL pipelines can easily be just taken, and you can actually either change some of these operators, induce some of your custom operators into this, and create your own application. So as we just saw this example from JDBC to JDBC. So imagine if you let's say have to read data from a Kafka and write to JDBC, that is easily doable. If you're reading from JDBC and let's say you would like to write to HDFS or Hive, so we have separate operators for that. That can be taken from the MapR library. I think there was a question on Phoenix, so I think Phoenix has a JDBC API, so that this particular operator can be used for that, or our HBase operator can also be used because Phoenix ultimately is kind of a wrapper over HBase, so that can be utilized. So we would request those who are interested to try these app templates. It would really help you to get going with your application at a faster rate. And please do provide your feedback as to how you're able to utilize these app templates in your environments. So if you'd like to send some feedback, please do subscribe to this forum, groups.google.com, or you could email it to us at dt-users@googlegroups.com. We will take some questions now.
How long the sandbox will be available after registration?
It's available. I mean, there is no period to it. Once you've downloaded it, it's available for you to utilize forever as such. We as and when we make a release for our RTS, we also make a parallel release for the sandbox.
So, and there is a question: can I run Apex with JDBC load on Azure HD Insight and Active Directory configurations?
I think that is doable. So these are some of the resources that I'm sure the audience would be interested. So those who are interested in taking a look at Apache Apex, this is the link, apex.apache.org. Please feel free to subscribe to our community at the Apex community, and we would be grateful if people would be interested in contributing to the project. It will be great for us, and you could try out what's happening in the community. Please be a part of the community. Those who are interested in downloading RTS, this is the link, datatorrent.com/download. We are there on Twitter. Please, those who are interested in Apex can follow us on Twitter, and as well as DataTorrent. We do conduct physical meetups, so this is the site where you could actually register and look at the future meetups that are being conducted. As I mentioned earlier, the video of today's session as well as the slides would be available on YouTube and SlideShare. There are future webinars which will be organized, so please do look out for them at datatorrent.com/webinars. We also have a startup accelerator program. This is a pretty unique program that DataTorrent is offering to organizations who basically fall in our startup definition, which is any organization that has a revenue less than 10 million US dollar and funding less than 30 million US dollar. So we consider this particular organization as a startup, and as per our offering, we are providing the enterprise license of RTS free for a year for a non-production environment. So one could actually utilize it as a startup license for a year in their development environment. So we understand the nature of startups, being a startups ourselves. So we would like to partner with any such startup who's interested in looking at our RTS offering. Please feel free to contact us. Please look at this particular site, datatorrent.com/product/startup accelerator. Those who are keen on the application templates, we would really love them to try out these AppHub templates. This is the link for it, datatorrent.com/AppHub, or you can download the RTS offering from DataTorrent. AppHub is a built-in part of DataTorrent RTS.
So there has been a question like how the loss of data is being taken care by transformation. So I hope you mean when the data is given from the JDBC input to transform, and if there is some failure, or if one of the CPUs or the nodes goes down where transform was running, so in that case the data is actually stored in a place we call as buffer server in our terms, and then when the operator in a recovery, there is automatic recovery for Apache Apex. It is a very good in fault tolerance. It has took all the care of it. So when it goes to an automatic recovery stage, the tuples will be then processed from that point itself. So there will be eventually no data loss. We store the tuples at a safe location, and it will be stored on the input side from the operator where it's getting the input. It's actually a PubSub mechanism. So you actually pull the data from a location. Thank you.
So this is an exciting moment for DataTorrent. We've been growing exponentially. Our investors have shown a lot of faith in us, and the project has garnered a lot of interest. We basically went from incubation in mid of 2015. By end of April 2016, we were a top level project. So the Apache Apex as a project overall has been doing extremely well. There's a lot of contribution. There's a lot of faith in the project, and as a result, we are really growing pretty well, and we need to hire. So if you're interested in being a part of this exciting team at DataTorrent, please feel free to send your resume, or if you know people who might be interested, to send the CVs, resumes, profiles at jobs@datatorrent.com. So these are some of the profiles that we are looking at. We would like to thank everyone for taking our time and participating in today's session. We really welcome all of you. Please do look forward to the upcoming webinars from DataTorrent. And as we mentioned, the YouTube video as well as the deck will be available on SlideShare shortly after this particular session.